This lesson's about solving inequalities, and one of the big things I want to kind of explain to you about it is that you need to show by checking. We'll talk what that means here in a bit. So in general, we have these things called open sentences, which are like equations, but open sentences are anything really with an equal sign or an inequality. So that could be a less than, a greater than, a less than or equal to, a greater than and equal to, or even a not equal to. Those are all the inequalities. And these things are called equals, and these are called inequalities. And we're going to be working mostly with inequalities today. If I had to give an objective, what we want to do today, it's to manipulate inequalities in order to solve. And the emphasis there on the inequality part. Manipulate inequalities in order to solve. So, a few little review items. When I have something like this, this means that A is to the left of B on the number line. A is to the left of B on the real number line. And we have worked on the real number line here before. And so if A is smaller than B or less than B, and this symbol means less than, then when I plot it out, I have A here and B there, putting closed points down to represent that I'm talking about ordered pair, or not ordered pairs, but just points. Then I could say B is greater than A, and that same relationship holds. That means that B is to the right of A. If I put another point down here, like maybe a small point C, I could then say that B is less than C. I could say that C is greater than B. I could say that A is less than C. I could even say A is less than B, which is less than C. Something that sometimes people put is they'll say something like let me see this kind of with this. Let's say B is less than C, which is greater than A, and I can't do that because this doesn't make sense for what this is doing. I can't tell what B and A are doing, so don't ever write that. But these are all inequalities or compound inequalities. Now, the big thing that I want to kind of introduce today are these different properties. So we're going to have a few listings of properties before we launch into this. We have the transitive property. And the transitive property says that if A is less than B and B is less than C, then A is less than C. And if I look right up above, it's exactly the image we're drawing here. A is less than B, B is less than C, so A is less than C. And then similarly, I could say if C is greater than B and B is greater than A, then C is greater than A. And that's true here. C is greater than B, B is greater than A, so C is greater than A. We have some more properties. This next one is called the addition property of order. What this says is if A is less than B, then A plus C is less than B plus C. You guys should actually remember that as the addition property of equality. So I'm going to kind of nickname this. This is just the add to both sides rule. It says you can add to both sides. One more. and then we'll launch into some problems. This is the multiplication property of order. And what the multiplication property of order says is if A is less than B and C is positive, then AC is less than BC. This is the multiply to both sides. Then, if A is less than B and D is negative, it's a negative number, then what I say is AD is greater than BD. I should switch back to black. What that means, what I kind of nickname this as is this is the switch sign rule. Here, BD. This is the switch the signs whenever you multiply or divide by a negative. And we'll practice that one a lot here. Okay, so those are the multiplication properties of order. Number 1. X minus 7 is less than or equal to 16. We're going to solve and we're going to graph. So what I'm going to do is I'm going to add 7 to both sides, and I get X is less than or equal to 23. Now, as a graph, what that means is I'm going to put a point at 23, and maybe I'm going to stick an origin point at 0, but I'm actually going to put a closed circle on 23. And off to the side here, I'm going to kind of make sure you know that less than or equal to or greater than or equal to means closed circle. And then we're going to shade in the correct direction. Well, X is less than or equal to 23 means we're going to shade in this direction. Then, like I said up above, we're going to test a point that's in that region. So I'm going to pick 0, and we're going to test 0. So I'm going to go back and I'm going to plug it back into the original. 0 minus 7 is less than or equal to 16, or negative 7 is less than or equal to 16, and that is true. Which means since it's in the region I shaded, it should be true. And since it's true, I'm then going to take this and I'm going to put it in set notation. All x such that x is less than or equal to 23. And that is my solution. This is all work that I need to see on every problem for this assignment. So, suck it up, you're going to have to do this. Number 2. P over negative 13 is less than or, let's make it less than, negative 3. Well, P over negative 13 is P divided by negative 13. And if I want to get rid of the fraction, I'm going to multiply the left side and the right side by the least common denominator of negative 13. So this gets multiplied by negative 13, and this gets multiplied by negative 13. Now, when I multiply this left side by negative 13, I just end up with P. When I multiply the right side by negative 13, I end up with positive 39. But this sign underwent a little bit of a switch, because when I multiply the left and the right side by a negative number, my sign has to switch. It's sort of like a compensating thing. Now, we're going to go number line. I'm going to graph 39. I'm going to put an open circle, because when I have less than or greater than, that means an open circle. And it's greater than, so I'm going to shade to the right, representing every real number greater than 39. Then I'm going to check, and I can test 0 again. 0 is somewhere over here, so I don't want it to be true. When I put 0 over negative 13 and check is that less than negative 3, I get 0 is less than negative 3. This is false, but that's okay because I picked a number that's not in the shaded region, and that works. I wanted it to be false. That just makes sure I shade in the correct direction. And then I'm going to plug in all p such that p is greater than 39. And that's my final set notation. For number 3, let's do a plus 4 is less than a plus 1. Well, we typically want to get the variable on the same side, so if I subtract a, oh dear, I get 4 is less than 1. When the variable drops out, just like we did with equal signs, when the variable drops out, check if what is left is true or false. This is false, which means that no variable will ever make that true, which means empty set. There is no solution. And if I graph that on a number line, it's going to look like a pretty lonely number line. I just put the origin down, but there's no point there because I don't want to shade any point. And my set notation solution is that. Number 4, 7j is greater than or equal to 16j minus 18. So I still want to get the variables by themselves. So I'm going to subtract 16j from both sides. And I get negative 9j is greater than or equal to negative 18. Then I'm going to divide both sides by a negative 9 to get j and 2. But because I divided by a negative, I need to switch this sign to become a greater than or equal to, or sorry, less than or equal to. I'm going to throw down the number line. I'm going to put a 2 there. Close circle. I'm including 2. I'm going to stick a reference origin, but it doesn't matter really where I put that, as long as it's to the left of 2. And then let's test 0. I'm going to test 0 and plug it back into the original. If I plug it back into the original, I get 7 times 0 is greater than or equal to 16 times 0 minus 18. Or 0 is greater than or equal to negative 18. And that is true. Now, notice how I tested it before I started shading. I can test and then shade. Since this is true, I want to include 0, because 0 is a solution. So I'm going to include 0 in the shading. I would shade in the direction that includes 0. And if I go back and I check, yeah, that matches. I want to be less than or equal to 2. Okay? So j, such that j is less than or equal to 2, is my solution. Number 5, 6 times the quantity 2 minus x is less than 3 times the quantity x minus 2. Distributive property makes that 12 minus 6x is less than a 3x minus 6. If I subtract 3x from both sides, I get 12 minus 9x is less than a negative 6. Subtract 12 from both sides, get negative 9x is less than a negative 18. Divide both sides by a negative 9, remembering to switch the signs, and I have x is greater than a 2. Number line, put a 2 down, put an open circle on the 2 and stick an origin point down, and I'm going to test 0. I'm going to throw it back into the original problem. 6 times 2 minus 0 is less than 3 times 0 minus 2, or 12 is less than a negative 6. That is false. So I want to shade in the opposite direction, not with 0, but I want to shade over here to the right of 0, or to the right of 2. So I'm going to start shading that way. And that matches greater than, so that's a good match. X such that x is greater than 2. Number 6, I have 3/8 y plus 1 is greater than or equal to 9/8. My first step here is to realize I have eighths, so I'm going to want to do a least common denominator of 8. Multiply the left side and the right side by an 8. When I do that, I'm going to distribute here and get 3y, and distribute here and get 8, and then multiply here and get 9. Subtract 8. 3y is greater than or equal to 1. Divide both sides by a positive 3, so my sign doesn't switch, and I get y is greater than or equal to 1 over 3. Let's throw down a number line. 1/3, close circle. Put down an origin, just as a reference, and then I'm going to test. I can test 0 again. Back in the original problem, 3/8 times 0 plus 1 is greater than or equal to 9/8. That's 1 is greater than or equal to 9/8. Now, 9/8 is 1 and 1/8, and 1 is not greater than or equal to 1 and 1/8, so that is false. So I want to shade in the other direction, which matches this. So my solution is all y such that y is greater than or equal to 1/3.